All right, so this is where we were. We might not have been able to see this area here before, but we have cooling process, heating process, burns, surface area, snow, shower, firewalk, shower curtain, convection. I think that's where we were, correct? Okay. Let me erase a little bit of this, all right, so I can go over this and finish quickly. Okay, Anna's like losing it. Okay, it's all right. Okay. So, this is what happens. It's something called, and I'm actually going to teach you some, how you get, the way you get lift in an airplane. Like, this is chemistry, we're talking about airplanes. Okay, you ready? Okay. This is a cross-sectional area of an airfoil, a wing. Okay, that's what a wing looks like. A wing is like that on the top and like that on the bottom, right? Clear? Now, let's say the wing is going this way. Okay, is that okay? All right, now. Yeah, the wing is going from left to right. The wing is going from left to right. Okay? Now, think of it this way. You ready? Think of it this way. There's 2 molecules of air right there. Okay? 2 molecules of air right there. And the wing's going that way. Clear? Okay, now. So, if this wing, obviously the top and the bottom are moving at the same, are in the same wing, so it's all the same, right? Okay, so going from here to here, T at the bottom equals T at the top. Right? Right? In other words, the time it takes for this molecule to go here is the same time it takes for the molecule to go there. Right? Correct? Does that make sense? A little weird? TJ?
But isn't it going like in a curve and one's going straight?
No, but look, think about it intuitively. The wing is, let's say that the molecules aren't moving. And here's the molecules. You ready? You ready?
Yeah.
Boom. Didn't the top go through these molecules at the same time the bottom went through the molecules?
Yeah.
So didn't the molecules travel? Top molecule and bottom molecule, didn't it travel the same amount of time?
Yeah.
Didn't it? Okay. The distance at the top is bigger, right? The distance at the bottom is smaller, right? Correct? All right, now, velocity is big D over T, right? Correct? That's the velocity on top, correct? Yes or no?
Yeah.
Yes or no? That's the velocity on top, right? I can erase this. Okay? The velocity on the bottom is going to be smaller, isn't it? Look. Smaller d, right?
Yeah.
TJ, you with me?
Yeah.
Smaller d, same t though, right? These t's are the same, aren't they? This distance is larger, therefore large over small is going to be larger than small over that, right?
Which is the velocity?
I'm sorry, large over t is going to be equal a larger number than small over t, correct? Yes or no?
Because the velocity at the top is going to be faster than...
That's correct. Right, that's correct. Okay, now, listen carefully. I'm almost there. I'm almost done, guys. I'm almost done. Okay. So the velocity of the fluid is large, isn't it? The velocity in the bottom is smaller. Isn't that true? Right? Yes or no?
Yeah.
Okay. This is what we call Bernoulli's. Look up Bernoulli and I'll spell it on the board. Look up, try to figure it out. Look up Bernoulli. Okay, are you ready? You ready? I can erase this? Bernoulli. Try to figure it out.
What's this? Bernoulli. Oh. Bernoulli. He said Bernoulli. Oh, Bernoulli. I was going to write that.
They're looking, I'll tell you. Nothing like learning how to spell a word by looking it up. Like, how do you spell that? And you have to experiment and figure it out, okay? Now, you ready?
Which is the cars guy?
All right.
Yeah, the Italian one. He's green. If I don't even do that, just really know.
Okay, you ready? Are you ready? You ready? Can you see this? This come out? You ready? This is Bernoulli's principle. Are you looking it up, TJ? Are you there?
Yeah, I am there.
Okay, well, let me do this first, and then we'll look at Bernoulli's principle, and you can tell me in one sentence or less what it is based on what you found.
Yeah.
If I have a fluid flowing from left to right, okay? A fluid, like a hose. Think of a hose, right? The faster that fluid is flowing, the lower the perpendicular pressure. So this is flowing very, very low velocity. Okay? Very low velocity. You can have high pressure. Relative to high velocity, low pressure. Do you see that?
Yeah.
So the faster the flow of the fluid, the smaller the what? Perpendicular pressures. Now, what does that have to do with the curtain? Well, let's take that curtain. Here's the curtain, right? Here's the curtain. And here's the flow of the fluid in the shower, right? 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 Let's take the shower curtain and go like this, and my breath will be the water. I'm just taking everything and I'm turning it, okay? Is that all right?
Yeah.
Okay, you ready? Here we go. Here's the inside of the shower. Here's the outside of the shower. You ready?
Oh.
See that? Is the fluid flowing on this side of the shower curtain? No, it's not. Only on this side, right? So where is the pressure going to be reduced, on the top or the bottom? Where is the pressure going to be reduced, on the top or the bottom?
The bottom.
Right? On the top, you're going to reduce. I know. Abdullah, you are wonderful. I'm going to give you extra credit today because of your sense of humor. Okay? Okay? Okay. I'm telling you, he has the most sophisticated wrong answers. You work at it, I'm telling you. If you put as much energy in getting the right answers as you do the wrong answers, you would be a famous scientist. You are, it's remarkable, it's wonderful. Well done. Okay, now. Has he been right yet today? I don't think so.
No, I don't think.
Is that all right? Now you want to, this is a record, so you're going for the record, so don't be right. Okay, but you got to try being right. Okay? You got to make it look like you're actually trying to be right. Okay, good. All right. So on the inside of the shower, now you have the flow. See, that's coming in. See that? You see that? Annoying, isn't it, that shower curtain? And why am I going over shower curtains? And I mean, am I losing my mind on a Thursday? You know, TGIT, because we don't have off, right? We have off Friday, okay. Why am I losing my, no, because, look, gases and liquids are fluids. We're talking about properties of fluids. Okay, hang out. Everybody's like ready to like scratch my eyes out, right? Okay, I'm almost finished. Okay, good. And why do pigs roll in mud? Why do dogs pant? And we said, what holds more energy? A kilogram of iron or a kilogram of water? And we said that, now I'm rounding off, all right, just give me some latitude here. Water holds 10 times, almost 10 times more energy than iron. Look up hurricanes. How does how does that work? Where does it get all that energy? It gets from the water. The sun beating down on the water, absorbing this incredible high quantity of energy. So pigs will roll around in mud because they don't have pores. That water will evaporate. So evaporation, is evaporation a cooling process, Abdullah, or a heating process?
Cooling. No,
Yes, you got it right. Yes. So from the pig's point of view, okay, who cares about the pig's point of view? We do. Well, all right, fine, I do. Okay. From the pig's point of view, the pig is rolling around in mud. The two major ingredients of mud are dirt and water. So, water, duh, yes.
Hurricane.
The water, hurricane. The hurricane and the pig. Okay. So, the water evaporates from the pig, takes the energy with it, the pig cools. The dog pants out, gives off water vapor. The water vapor contains heat. The dog cools. You, today, sweat. You sweat. You still look like you're sweating. You sweat so much. Okay? Yeah, you do. How many people sweat today? Raise your hand. Yeah, only half the class is raising their hand. I don't believe you, Kaylee, okay? Don't even go there. I don't believe you. You sweat. Okay, fine. Now, and why do you sweat? To cool you off. You sweat, and the sweat evaporates, and evaporation, in order to evaporate, you need energy, right? Well, where's it getting the energy from? It's getting the energy from you, right? So evaporation is a cooling or a heating process.
Cooling.
Yes, Abdullah, I am impressed. Okay, now, barometers. If I have a barometer made of mercury, it's only 760 millimeters tall. Yes? If I have a barometer made of water, it's 10 meters tall. Yeah, so you can make a barometer out of water, but it's just going to be tall. It's difficult to have a barometer made out of water in a classroom. You need a 10 meter building. Classroom. All right, so let's keep score here. Let's see if we have this. Oh, we don't have this thing over here. Let's go down like that. Okay. All right, so I can actually put this up like this. So here we have the barometer, 10 meter barometer if it's made out of water, 760 millimeters if it's made out of mercury. We did that already though, right? Look at this. What is the pressure of fluid dependent upon? Well, here's the equation for pressure, F over A. Did I do this in your class?
No.
Okay. There is a video online, okay, that I made. It's dependent upon density of the fluid. It's dependent upon gravity, and it's dependent on the height. So, you're in a bathtub 1 mile deep and you're at the bottom.
Yeah.
What has more pressure? Just a small bathtub at 1 mile deep. 1 mile deep in that bathtub or 1 mile deep in the huge Pacific Ocean? What has more pressure? Same. As long as it's both water, same. I know, fine, salt water's heavier, but let's say it's all water. Okay? All just water. So it's dependent upon the fact that it's water, right? Look. This pressure depends on the fact that it's water.
Yeah.
Depends on the fact that it's planet Earth. And depends on just the height in the water. You could be under a bathtub, a mile of water in a bathtub, or a mile of water in the Atlantic Ocean. Doesn't mean that because there's more water above you, it's going to be higher pressure. It's the depth, and the fact that it's water, and the fact that you're on Earth. Clear? Okay. Hot, cold, shema. Okay. Let's look over here. We have convection, shower. Okay, what I'll do is I will move this back and I'll leave what's on there. And hey, I'm done 3 minutes early. You guys were great. I'll leave this on, and I know that a lot of you are going to want to stay and take a lot of notes. So, you know? Oh, I'm so surprised. All right, get out of here. Have a great weekend. And get some sleep, girl. You look like you worked hard. Having fun takes a lot of energy. It does. Abdullah, I'm telling you, extra credit, big guy. You did. You. I'll tell you. The end is always more important than the end. Well done. Up. You just walked right in front of the camera, girl. You are online.